Okay, so thank you for coming. My name is VLAD MIHALCEA, and today I'm going to talk to you about not just Hibernate presentation tips, persistence tips, but also about Spring, JPA, and also JDBC, because when you're working on a project, you'll see that all these frameworks and technologies are going to be blended and mixed, and in the end, you have the data access error, which you need to address uniformly. Okay, so first, a little bit about myself. I work for the Hibernate project, where sometimes I work as a developer advocate, but most of the time I'm just doing development. And my priority for this framework is to make sure that it works as fast as possible for the developers using it. So in this presentation, we are going to see some features we've been adding recently, not just in Hibernate, but also in Spring. We've been collaborating with the Spring framework guys to make sure that the performance-related features we have in Hibernate are also made available when you configure your application using Spring annotations. Okay, let's see if it works. Okay, so the first, all these tips are going to be grouped in several sections. The first one is about mappings. One thing to keep in mind when it comes to portability, if you have identifiers, if you want to have identifier portability, and you take a look at the specification, you will find this identifier generator called the table generator. And for instance, if you're developing an application and you need to address database systems like MySQL or Oracle, PostgreSQL, you'll see that there's no way you can find one identifier generator which works on all of them, because even if, for instance, nowadays Oracle 12 has introduced support for identity, and for instance in MariaDB now you have support for sequences, there is still in MySQL you only have identity. So there is no one single identifier generator you could use. So the table generator is very appealing because you can just set it. It's just one annotation which you need to provide at the entity level, and it will address all your portability problems, and then you can just deploy your entity and it will work. And actually it will work on every environment, but it has one impact. You have to think about it. How does it work behind the scenes? So you have your entity, you have the table that represents your entity, and then you have an extra table that's being created by Hibernate called the Hibernate sequence. So basically what Hibernate tries to do is try to emulate what a database sequence would otherwise do. It tries to emulate it with, using a separate database table. So how does it work? For instance, if you want to insert 3 entities, Hibernate behind the scenes will have to use a separate transaction for generating the identifier. Why? Because the database sequences are non-transactional first. They have to be like that, because if they were not like that, you'd have to keep a lock on the identifier until the end of your transaction. So then you would introduce a bottleneck. So that's one thing. So the very first thing you have to keep in mind is that the amount of database connection that you would need at some one point of time when you use the table generator actually doubles. So that's one concern. The other concern is how the identifier are being generated. So for instance, you see here that you use the table, you have to use select for update, which has to lock the record in order to make sure that all the transactions that want to generate identifier, they can generate the identifier monotonically, and then you want to make sure that 2 consecutive transactions don't get the same number. That's exactly the same thing that happens with identity or database sequence. So you need to have the same semantic. But that takes, for instance, using a table level locks to do that poses a very heavy impact on application performance, as for instance we will see. So actually this is what, in the end, you will get your inserts, and IDs are going to be generated there. But then if you have to compare how identity and table generator behave, or how they compare one to another, you will see that the more threads you are going to add to your application, the more time it takes to generate the identifier generator using the table generator compared to identity. So even for MySQL, in this case, it's still a much better idea to just use identity. And for instance, if you have PostgreSQL, the blue line, which you can barely see for until 8 threads, that sequence and then you have the table generator. So it does not perform very well. So you always have to think about it, that it's very easy to just throw some mappings to your application, but then you have to pay attention to what exactly happens behind the scenes, because in the end, when it comes to performance, it's all about the very little details. So now, what's also interesting is that this is what people do most of the time. Sometimes they put the auto-generator, sometimes they even omit it, and the auto-generator is the default. This is a very standard mapping. However, if you're using, for instance, MySQL, it really matters what's going to be mapped for the auto generation strategy. And prior to Hibernate 5, auto would default to native, which works something like that. If the database supports identity, it will pick identity, otherwise it picks sequence. However, since Hibernate 5, the behavior has changed. Now the auto maps to sequence style generator, which if the database supports sequences, it will use a sequence. Otherwise, if it does not support sequences, it will fall back to table. So, for instance, in MySQL, if you're using MySQL and Hibernate 5, then it will fall back to table, and you don't want that. So what you can do, you can either use native, for instance, and then it will use identity, or you can just use identity. But this one is going to give you a little bit of portability. Or, for instance, you can do something different. For instance, you can just map your entities using the sequence. So, for instance, you want to support Oracle, PostgreSQL, and MySQL. You can still use sequence, and then that will apply to most databases which already support sequences. And then for MySQL, you can use one property of JPA, which allows you to overwrite. Using XML mappings, you can overwrite annotations. And in this case, we only need to overwrite the strategy for the identifier. Everything else can be inherited from annotation. So actually, you can solve this portability issue at build time, at deploy time, where you just inject the right profile-specific configuration properties there. So actually, you can still solve this portability problem, even if you don't use the table generator. Okay, now, another thing that's also related to mappings, and it's very important to think about it, is, for instance, Hibernate defines, both JP and Hibernate defines a set of mappings which you can use, and they are common to all databases. For instance, you have numerical column types like integer, long, and then you have the variable character, you can have blob, you can have almost all basic types which are supported by all databases. However, that's not enough. For instance, there are databases which go beyond that, and those types are not supported by Hibernate. And for instance, assuming that you have some events in your applications which store some IP address and you want to store them. For instance, if you don't have support for, if you don't have native support for IP addresses, you could either use a varchar, but that would take a lot of space, 18 bytes, which is quite a lot, especially if you want to use an index for that. Or you can use 4 bytes plus another byte for the network address. Or, for instance, in PostgreSQL, you can use a dedicated type, which not only that it's very compact, but it also provides you with capabilities like, for instance, here, you can just use a query where you can get all events where the IP belongs to a given class network address. All events are generated for this specific network address. And then you'll get your event, because this one belongs to these network addresses. So not only that it's much more compact, but it also allows you, it gives you more feature, better functionality. So if you do that, if you want to use such a type and you want to use the inet address, but with Hibernate and you don't have support for it, by default, if you don't use a specific custom type, it will just map it to a variable, to an array of bytes or some serializable type. However, if you want to use, in this case, if you want to use the specific type, then you have to just create, you just have to create a new type. And you don't even have to create it yourself, because most of the types, you have it available in this project, which I created on GitHub, and it supports lots of types which are not supported in Hibernate. However, they are supported in PostgreSQL, like, for instance, array, JSON, PostgreSQL-specific enums, or IPv4 or IP addresses and stuff like that. What's nice about this project is that even if we added support in Hibernate for this, that would be available from the latest version. So for instance, if now we integrate this, you will get it in 5.4. However, if your application uses Hibernate 4 or Hibernate 5.1 or 5.2 or something like that, which comes with either your old Spring dependency or via your Java EE application server, then you would not get access to it. Using this is much simpler because you get access even if you're using Hibernate 4.1, so you still have support for it. Another thing which also brings you is support for JSON. And I remember that we used to develop, before joining Hibernate, we developed one application, and at some point, we needed support for JSON. But back then, PostgreSQL didn't have support for it. And we wanted because we got some data which was not formatted. We couldn't not just save it in a relational fashion where it's validated against a fixed schema because the schema was different from one provider to another. So we wanted to store that. And because we didn't have anything in Postgres to use, we had to use MongoDB for that. But that using more databases increases not only development cost, but it poses a lot of risk and also a lot of pressure on the operation side because you have to take care of security updates, you have to take care of monitoring, you have to take care of backups, replication for that. So it increases, it adds more complexity to your operation as well. Nowadays you don't really have to do that. You can just use JSON node from Jackson and the JSON node binary type, and you get support for it. So even if it's not supported in Hibernate, you can get it via other open source project as well. So for instance, you can just save. Here these properties can have any structure you want, and then when you update it, you can just add more properties, or different entities can have different JSON representations inside. So yes, that's also very, it's very good to know about it because you have support for it nowadays, so you can simplify your development. Okay, now one thing which is few people actually get to understand how much they can benefit from statement caching. Usually people, when think about caching, they think about the Hibernate second-level cache or application-level caches like Redis or Memcached or database caching. However, you can still gain a lot with just configurations, using just plain JDBC configuration from statement caching. And how this really works, now if you're using Oracle or SQL Server, you're lucky because you also have an execution plan cache, which really works great in these database servers. You don't have it for MySQL or PostgreSQL, but if you can take advantage of it, it's really worth to adjust your queries in order to make sure that you get a very good cache hit for the execution plan cache. And for instance, how does that work? In Oracle, for instance, every time you have a cache hit for the statements for the execution plan, that's going to call soft parse. Otherwise, if the plan has to be recalculated, you have a hard parse. Now, caching an execution plan is not very easy because the database needs the data distribution. You can have columns, which for instance, like a status column, which has a done value, and that would apply to 99% of the table, and then a to-do column value, which only applies to 1% of the records there. Based on what value you're given to your query, the database can switch the plan from using an index, if it can get a small subset of data, or it can use a full table scan if it has to parse almost all the table. So that's calling on Oracle bind picking and adaptive cursor sharing, because it can, based on the data you provide, it can switch from one plan to the other. So it's not just one cache that's going to be added to the statement cache plan, to the plan caches. It can actually use multiple caches based on what data you are given, even for the same statement. So this is quite an interesting thing, and you should keep it in mind. The same, for SQL Server, it's almost the same. It's just the terminology that's called differently. For instance, parameter sniffing is what bind picking was for Oracle. And what's important to know is that you have to use the fully qualified database object names when you write your queries if you want to maximize the chances that you get a statement cache hit. For PostgreSQL, they used to have an execution plan cache, but not anymore because it was not a very good implementation. And actually, using an execution plan cache, which gives you the wrong plan, is worse than just generating the plan over and over again. And one thing it's important to realize for Postgres SQL is that usually when you're using prepare statements, you think that you have a clear prepare phase and an execute phase, which happened in different database round trips. At least this is the theory and what you would assume that it works like that. However, in reality, it does not work like that. Until you hit this prepare threshold, which is 5 in Postgres SQL, both the prepare and the execute phase are going to just go in the same database round trip. So actually, the prepare statement is emulated. It works more like a regular statement would work. The reason why they do it like that is because they realized that most statements are executed only once. So it doesn't make any sense to just go with 2 database round trips when you can just do the same with 1 round trip, and actually it's going to be faster. And for MySQL, it's the same. You don't have an execution plan cache, but you can play with these 2 configuration properties in order to for instance, to activate the statement cache, either on the server side or on the client side. Because also on the client, what I talked previously was what you can cache on the server side, but you can also cache, for instance, on the client side, on the JDBC driver side, and there you can recycle, for instance, objects, either these objects given by JDBC or objects used behind in the implementation given by the JDBC driver. And also, when you're using a database cursor, that also applies, and it's the same thing like statement caching. And for instance, in Oracle, you can just activate this property, which is, and then you can activate the implicit statement cache size. You have to provide the cache, how much the cache size how many statements it should hold, and it will apply to all the statements. If you have statements which don't have to go to the cache because they are executed rarely, then you can just skip them using this. This is standard JDBC API using setPullable. You also have in Oracle, you have another, which is called an explicit statement caching API. You have to enable it, and then you have to configure the size. However, you have to pay attention to, you have to make sure that data and execution state does not leak from one state to another. So this one is a little bit riskier than the other one. And also, it's not very applicable as well, especially if you're using JPA Hibernate or other frameworks, because you have to use this non-standard JDBC API. This one is strictly related, and it's bind to the Oracle API. So it works like that, because when you close the statement, you actually have to close it. You have to return it to the statement cache pool, and then you have to get it from the statement cache pool using its specific key. Okay, so also in SQL Server, nowadays, SQL Server, the driver of SQL Server is on GitHub, and actually it's very well maintained. Previously, it was not like that. For instance, many years ago, I don't know if you worked with SQL Server. There was an open source driver called JTDS, which was good like 5, 7, 8 years ago. But nowadays, it's not a good option because it's stuck to JDBC 3. So nowadays, actually, the Microsoft driver is better. And this one is quite recently. They even added support for statement caching. They had this property before, but when you activate it, it would just throw an exception. So nowadays, if you use it, and then if you configure the cache size, actually you can benefit from statement caching. So actually, that's not really common on many projects, because when you start a project, you just put the JDBC driver version there, and then you never touch it. So actually, you can even predict how old the project is by just looking at the JDBC driver version you find in the POM XML file. Actually, it's a good thing to just upgrade it from time to time, not just jump to the latest version, but at least to one version which is quite stable. Because they fix bugs, they introduce new features which you can use, and actually you can benefit from the performance improvements they add to the driver. And also in Postgres SQL, this is also, like 2 years ago, they did support for statement caching, where you can configure the cache size and how much you can hold there, and actually it can speed up your queries just fine like that. and in MySQL as well, using the same properties that I presented previously. You have to enable the cache prepare statement property, and then you have to configure the size and how long the statement can be. And for instance, if you just measure performance, how much you gain, for instance, on 4 different databases, you will see that if you let it run for 1 minute and keep on executing some statements, you get quite, depending on the database, you get quite a significant performance impact by just playing with the right statement caching configuration. So this is an easy gain. For instance, you don't have to change your code, you just have to configure it properly and it will work faster. The next thing I'm going to discuss is about optimization for queries, which we've been adding in Hibernate. Like for instance, this one is for criteria API. The way the literal are handled in Hibernate, traditionally it was something like that. So for instance, if you had strings, then Hibernate would use bind prepare statements. However, if you had like numbers, then Hibernate would just use the literal instead. However, if you're using the same, like I talked before, if you're using Oracle or SQL Server, you want to benefit as much as possible from reusing the execution plan. So there, you want to use bind prepare values even for literal. It would make quite a lot of sense to do that. So now, that's exactly what we did. This is the default mode I presented you. So now you can use the bind mode for Oracle if you want, and then Hibernate will switch to using bind parameter values, and you will get a better chance of reusing a given execution plan for a statement if you do that. Also, another optimization which was also added recently is in regards to the in clause. For instance, when you're using an in clause, something like that, depending on the number of parameters that you are giving, Hibernate is going to vary the SQL statement, so that if you have 3 parameters, then you have to have 3 bind parameter values. If you have 4, you need 4 bind parameter values, and so on. For instance, if you have 5 or 6, then you need to vary, because the gDBC API does not know how to, for instance, to pass one array and then to have in the inquiry only one bind parameter, pass one array, and then dynamically apply it to all the values inside that array. So for instance, here the problem is that because we are using different values, this is a different statement, and it will generate a different execution plan in the cache, and you don't want that. You want to maximize the chances of reusing an execution plan. So now, for instance, to do that, we added support on a new configuration value, this one. You don't have, all the slides are going to be online, and the video are going to be online. So just imagine that there are many features, so just acknowledge the features that afterwards you can just find all the parameters and then configure it in your application. This one is quite an easy gain. You just set it to true, and how does it work? It just, it changes, and then the size fluctuates on power of 2. So for instance, in this case, it goes up to 4, and then it just repeats the last values. So here you can reuse the same statement even for 3 and 4, and the same for 5 and 6, because it will use the same prepare statement, and it just repeats the last value, which actually looks like a hack, but in reality, actually, it works pretty fast. It works much faster, even if you do that, because the database is quite smart, and in the end, it will just know that you keep on passing the same value at the end, and it will just discard it. So actually, this one works way faster than not doing it. On what databases? Especially on Oracle and SQL Server, because there you have the execution plan cache, and you can take advantage of it. Okay, now this one about the query plan cache, this is few people get to understand how it works behind the scene, and how much impact does it have on your application. The thing is that when you express your queries using JPQL or Criteria API, that's a new language, it needs to be parsed. Hibernate does that. It has an abstract syntax tree which is generated from the query, and in the end you will get the SQL statement. However, parsing this entity query takes time, and for that Hibernate has been having this execution plan, query plan cache, entity query plan cache for a very long time, which by default holds 2,000 entries, and the other one is for native SQL for the metadata that you send to the parameters. So now, for instance, this is how much it takes if you don't use the cache. So it takes around 300 microseconds to parse that every entity query plan, and this is how much it takes if you're using the query. So what's important for you here to realize is that if you're using a huge application which generates lots of queries, especially if you're using Criteria API and you're always varying the statement itself, it might be a good idea to increase the cache to a higher value than the default one, which is 2000. How do you know how much you need? You have in Hibernate 5.4, we added support for statistics for the query plan cache size. Otherwise, if you have different older version of Hibernate, you can just monitor the parsing and then using the logging to see how much time the parsing happens, and then you'll get an indication that you might want to increase the value because it does not accommodate all the statements that you want. And for this one, 2000 statement is not enough. For instance, even if you raise it to 10,000, it will not occupy way more memory. And nowadays in a server you have a lot of memory. I have 16 gigabytes on my laptop, so for a server which has 128 gigabytes, it doesn't really make much of a difference that you put 2,000 or 10,000 there. And this is for the native SQL statements. It's not as much as an improvement as, for instance, it was for the entity plan cache, but still, it's still better than not using the cache efficiently. Okay, another thing which is, this one is also very important, and in order to understand it, you have to understand what happens in the database. For instance, if you have a scalar query like this one, where you have one property, and in this case, we actually want to have the distincts in the SQL because we want distinct results. Here we can have a post which is created in a year, but then we have many posts created in that year, and we're interested in distinct all the years where we actually wrote blog posts, and then we can use a query like this. So here using distinct is actually a good idea. However, distinct has a different meaning if you're using an entity query. Here, if you're using distinct, you're telling Hibernate to remove duplicates, because here you're joining a parent with a child, and then in the result set, then you have the parents repeated for every child. If you don't do that, you will get duplicates. So here you want to make distinct, but distincts only have a meaning in Hibernate. It shouldn't have any meaning in SQL. Here, however, if you do it by default, Hibernate will also add the distinct in the SQL query, and that's not desirable. It looks very, it doesn't look like much. If you take a look on the query, you'd assume that even if you add it, that's not much of a problem. However, in reality, it is a problem, because this is what your execution plan should be. It should end here. And you have two more phases. You have a sort phase and a unique phase. So actually the result set has to be sorted in the database because of the distinct. And this is just extra overhead, which actually brings no value to your query, because the result set already has distinct values. Why? Because you have the primary key of the child, which always has unique values. So here, these extra steps here are just redundant, and you don't want them. So what you can do, you can use this query hint, pass distinct through, you put it to false, and then you remove the duplicates in Hibernate, but then at the SQL query level, you no longer have the distinct. And then the execution plan is going to look like this, exactly like you want. When was the last time you checked the execution plan of your SQL queries? This is a very, very tough question. So yeah, actually, if you want something to be fast, you have to get down to the execution plan, because that's where, in the end, you'll understand what the database needs to do in order to execute your statement. Now, there are also things that were added for, and also, in order to understand the next one, about fetching, you have to understand what actually happens when you're selecting entities in Hibernate. People would assume that when you fetch an entity, then you just have the entity being cached in what's called the first level cache, or entity manager session, or persistent context, whatever you call it. However, in reality, you have more than that. When you load one entity, either from the database or from the cache, actually you have two things. You have the entity, and then you have this disassembled state, which the disassembled state is actually used for two purposes. It's also used for dirty checking, and it's also used, for instance, you have this one, you can cache. Actually, the second level cache is this object, is the cache of this object array. How it happens? From the result set, you get this object array, and when you hydrate it, you get the entity. So this is how. So when you actually load an entity in read-write mode, the impact on the memory is double than what you think, because you also keep this object array, because you want to have this object array when you're doing dirty checking, because you keep on modifying the entity, and then Hibernate needs to know if the entity was modified during the flush. So in order to know if you modified it, it has to have the loading time snapshot, and that object array is the loading time snapshot. So it uses it to compare all the properties and know whether it needs to generate an update or not. So for instance, every time you're loading entities, you're storing both the entity in the persistence context and the array. If you don't want to do that, because you don't need to modify the entities, then what you can do is to set the session to read-only, to true, or you can do it at the query level. And then the entities that you are going to fetch in read-only mode are not going to be checked during flushing for modifications. And there will be, the impact of memory is going to be much more efficient because you discard the array. You're not going to hold on it for longer periods of time. So it can actually, make the garbage collector work more efficiently, because the sooner you you discard it, the better you get a chance to be removed as soon as possible. So what we did about that, actually I took a look on the Spring framework to see how they actually implement behind the scene, what actually they do when you set this read-only true flag on the transactional annotation in Spring. And actually, I realized that before Spring 5.1, Spring Framework 5.1, what did they do? They only set the flush mode, the flush mode was set to manual, but they didn't do anything related to this read-only mode at the session level. So now, this was changed. I sent a pull request for them, and they integrated it. And now in Hibernate 5.1, you actually have this. So if you're using read-only entities, you no longer get that loaded state. You get the entity being cached, but then that state is going to be discarded. So yeah, if you're using Spring, you have to take upgrading to 5.1. You will get this optimization automatically. Okay, now related to pagination, this is important. Every time you want to fetch data, it's useful to use pagination. Because why is this important? Because fetching more data than necessary is usually the biggest problem, or the #1 cause of performance issue in application, not just in application with JPA and Hibernate, like in other applications as well. So for instance here, the difference between fetching 100,000 and 100 rows is quite significant, and usually you don't really need to select more than what you can fit on a page. Even if you have, especially if you have mobile devices, you only need to fetch just as much data that you need to resolve one use case, to just address one use case. But then in JPA 2.2, there is this feature, streaming support, based on Java 1.8 stream, and they added because it was uncomfortable using pagination, and they think that using pagination actually is not correct, which is actually is not. This is half true, because in reality, if you insert or delete entities from the pages, they will be immediately available to your pages, and that can be a problem or not. So actually, they added support for this. So in JPA 2.2, now you have for query, you have get result stream. Previously, you used to have get single result or get result list, and now you have get result stream, which gives you a Java 8 stream, which then you can use. This is not something new in Hibernate. It was there since Hibernate 3, it was called scroll, and it's based on a database cursor. However, in order to use a database cursor, you have to make some changes at the JDBC driver level, because you have to instruct at the JDBC driver level that you really want to use a database cursor. And how you do that? Depending on the database, on MySQL, you have to use to set the fetch size to integer mean value. On Postgres SQL, you have to set it on a positive value, and Oracle and the SQL Server the same. However, streaming does not influence the execution plan, as you will see. If you do something like that, if you have an index on the created on column, and then you want to use this stream feature, and then you want to see what execution plan is going to be used. Now here we are telling Postgres SQL, for instance, to you just use a fetch size, to use a database cursor, and only fetch 50 items at a time. And then we also use limits so that we only extract 50 items. So this, from a Java developer perspective, is very convenient to write something like that, especially because now you have this, you have support for streams at the query level. However, if you do that and you check the execution plan, you see that actually instead of using the index we had before, we get a sequential scan. And then the database had to scan over 5,000 rows to give you 50 rows. So this is not very efficient at all. Why it happened like that? Because even if you're using streaming and you're only fetching 50 elements, the database has no idea, because you didn't hint the database that you only want 50 entries, because setting the fetch size does not influence the plan. So actually here, the only way to hint the database that you're only interested in 50 items is to use pagination, because this one, as we saw, does not generate the plan. So, however, if you use pagination without any streaming, then you will see that you're using an index scan, and now you only scan 50 rows. So actually, streaming is more efficient, or is very convenient from a developer perspective, but it does not generate the best plans that you can execute. So the difference, there we had 5,000 rows, but there we could have 500 million rows. So you always have to think about it. It's not just how much data you fetch, it's also what plan was used to give you even those 50 records that you have in the database. So streaming, it might be worth if you want to iterate through all of them. However, if you are only interested in a very small subset of data, pagination is usually much more efficient. Related also to fetching, why I wanted to mention this is because it's by default you get it in Spring Boot. So how does it work? In Spring Boot you have it by default. So you have a filter where when you enter in the web layer you get the session open. It's not transactional at this point until you get into the service layer. Only here you have a transaction, and then all the operations you do are going to be transactional using the single database connection. But then if you get out of the service layer, then you're going to get back, the connection is going to get back to the pool, and then you go to the web layer. And now here, if you still have uninitialized proxies, like lazy proxies, collections or associations, then Hibernate, because the session is still open, can initialize them. And this really looks like a good workaround, but it's not, because the way they are initialized here is using auto-commit. Because in JPA, it's valid to execute queries outside of a transaction scope. You can do it in auto-commit mode. So actually here, if you want to initialize 100 proxies, you will have to go to the pool 100 times. So you have to compete for connections there. And it doesn't really make a sense. This is not a good way to fix this problem. The time where you really wanted to fetch all the data is here, using the same database connection. It's much more efficient to do it here, because here you can make sure that you minimize the time you hold on to the connection, because the smaller it is, the transaction, the more transaction you can execute in the same unit of time. And the biggest problem here in Spring Boot is that you have it by default, and actually at some point we wanted to, of course, switching from using Open Session View from 1 to 2 and disabling it would not be a very good experience for existing databases, but we wanted to have a warning to be added if you have it activated by default. Actually, you can go to GitHub and read this story. It actually took 1 year to get to the conclusion for the Spring guys to add that warning there. So it's very interesting. Just if you have time, this one is way better than any Spanish soap opera. It's so much drama in that post. It goes on and on and on, but they added in it. So eventually it was okay. However, in Hibernate you also have, if you want to deal with the lazy initialization exception in other ways, you have this property which is not advisable to set it. What's unfortunate is you can actually search it afterwards. You can go and Google lazy initialization exception. You will get to Stack Overflow, and you will get one answer with 100 upvotes, which tells you to do that. which is a really, really bad idea, because this one is worse than open session in view. Because at least in open session in view, you are reusing the session, but you're not reusing the connections. Here, you're not only that you're not reusing the connections, but you're not reusing the session as well. So this one actually works even worse than open session in view. So yeah, don't do that. And also, always question the answers on Stack Overflow, which have many upvotes, but also check the comments as well there to see. Because yeah, sometimes they are not very good answers, but they are quick fixes. That's why people upvote them. Batching. This is a very good screen capture I took from Reddit. Actually, this was about all sorts of things in JDBC. It was a post that I did there, and someone, actually this one kept my surprise, because there was one guy who said there that he only saw JDBC batch mode like 4 or 5 times in his career. Actually, this is true. This is what happens, because in JDBC, you have different API. Most of the time, if you want to do an update, insert, or delete, you're using execute update. And that's how you execute them. But then, if you have problems in production and you realize that you are processing a lot of data and you want to make it much more efficient, then you realize that you want to use batching to reduce the number of round trips to the database. So then you realize that what you have to do, you have to change the API, because instead of execute update, now you need to call add to batch and execute batch. So you have to change you have to change your data access code to do that. And that applies not just to JDBC, to other frameworks which don't execute queries automatically. However, in Hibernate, luckily you have this transactional right behind cache, which is actually the session or the persistence context, where you can just, when you're calling persist, it doesn't have to generate the statement. You just enqueue them. So only at the flush time, you can save them. Because of this approach, you have a chance here to automatically batch statements. And that's what Hibernate can really do. That's what happens. So when you call persist, you just enqueue the insert action. So during flush, you can have all your actions here, and then you can use one insert to add all of them. So also, when you batch them, this is for batch processing, you have to make sure that you keep the persistence context in reasonable bounds. So at various intervals, you have to flush it. That's usually pretty well known by people, to call flush and clear. What people don't realize is that it's very important to also commit a transaction, because you don't want to process 100,000 entities in one transaction. Usually, that's why it's called batch processing. You want to use multiple transactions as well. It doesn't mean that the last item, if it fails, you have to roll back everything. Usually, it has to roll back only the last batch. So when you replay, you only have to replay the last batch that failed, and then you can reuse all the operations that succeeded up to that point. So you don't have to rework everything. For Hibernate, by default, the batching is not activated, so you don't have it by default. So if you insert 3 entities, you get 3 statements generated. However, you can easily switch from that mode to batching with one property. If you do it like that, globally it will apply to all sessions, to all statements. Or, for instance, you can overwrite it at the session level using this method here, this property of the session. And then, when you're doing the insert, then you'll see that only one round trip will be executed, and then you have multiple bind parameter values sent in one go. So instead of going 3 times to the database here, you only go 1 time. So this is very efficient, because you don't have to rewrite anything. You just have to write one property, and everything will work fine. And that's not all. For instance, in PostgreSQL, they added something which is very interesting, because if you use JDBC batching, you will see that only one round trip went to the database. But then in the log, in the database log, you will see that indeed you used a single round trip, but then all the statements are going to be added one after the other. So the execution phase, the database does not batch, is not going to batch the statements. So what they actually added support for, you can do it either using the Postgres specific data source, or you can use it using the JDBC URL parameters. You can activate this rewrite batch insert mode, and then not only that you are going to use one single round trip, but then even the execution is going to be much more efficient, because it will execute only 1 time whatever you want to insert in your batch. So actually, there are optimization also in Hibernate and also at the JDBC level. And if you don't take a look on what they had support for in the JDBC driver, you will never know about all these features. Another thing also related to this is how the update works when you're using Hibernate. Assuming we have an entity like this, and then we want to modify. For instance, we have one property here, and we persisted. This one has a title, and this one also has a different title. And then we want to take the first entity and modify the title, and then for the second entity, we want to modify the lax property. And because we have the batching enabled, we can see that only one update is executed using two sets of bind parameter value. That was possible because the default update uses all the columns. So that's why the way the default update works, it allows you to benefit from JDBC batching, which is good. However, it also has some downsides because you are using all the columns, and if the columns are really big, it will impact how much data you send to the database. Also, because if you have indexes on many columns, the database will have to go through them to search all the index and then find the same value, which you didn't actually modify. It also goes to the replication, to the undo and redo log. Also for triggers, there is a big difference between not including the column and including with the same value. It will fire the trigger for that particular column. So there are also downsides. It's good for batching, but not always is a good default. Luckily, in Hibernate, you have this dynamic update annotation which you can use, and once you add it, then for the same statements, you will see that the update changes, and it will include only the properties that you have changed. This one will decrease the likelihood of using batching, but at least it will address the previous problems. So in the end, you will have to decide at the entity level, what do you want? You want the default behavior or this one, so you have a choice. Another thing which is also worth keeping it in mind, usually using merge for detach entity is a good idea. However, if you have many entities which you fetch in one request, you modified in a subsequent request, for instance, this can happen in one JDBC transaction. You view the result in the UI, and then you apply the changes. You send the changes back. You modify the entities, and now they are in detached state. At this point, they are not synchronized with the database. So practically, you have two options. You can either merge the entities, or you can use this Hibernate-specific update. The way the merge works, first, it must go and select. If you don't have anything in the entity manager, it must go to the database. So it has to select all the entities, copy the detached state, and then the flush will fire. So if you have many entities, you will have lots of select statements executed here until you get a chance to execute the update. And that's not very efficient. In this case, if you're using the Hibernate-specific update, you just skip all those select statements, because practically, how does it work? Hibernate, when you call session update, it just schedules the entity update, even if the entity was modified or not. It just forces an update for that particular entity, and that's why it just skips the select statement. So actually, this one, for some particular use cases, can actually be more efficient than using the entity manager merge. The last topic I want to talk to you about is about managing connections. And this actually is one improvement which we added support for. And what's nice is that you can actually, this one applies if you're using Spring or Spring Boot. This one applies to you, because if you're using Spring, most chances are that you are using resource local and not JTA. JTA is specific to Java EE application server, but when you're using Spring, you are using one database, you are connected to a single database. So using resource local, which actually means using one database and using the JDBC connection to manage transaction, this is actually the right mode. However, in Hibernate, for instance, when you're entering a method which is annotated with transactional, at that point, Hibernate needs to make sure that the database connection that you're going to use is not set to auto-commit true, because by default, the connection are in auto-commit mode. So it needs to disable the auto-commit mode. And the only way to make sure that it can disable the auto-commit mode is if you can actually get the connection. So what happens? You enter the transactional block, and then you immediately get the connection. And that can be a problem because you can do application-level processing, which, for instance, does not require a database connection, but you are still going to hold on to the connection from the very beginning. And that can take time. For instance, you can have something like that. You can do some read an XML document, you parse the document, then you extract the entities, and only here you persist them. If you acquire the if you acquire the database connection here, even before you read and parse the document, these phases actually are executed with the connection taken. And because you hold on to a connection, other transaction will have to wait for, because usually you don't have a lot of connection to share. So here, for instance, what you can do, when you configure your connection pool, Hikari is quite a good, it's a very good option if you're using connection pooling in Java. You can set at the connection pool level that the auto-commit mode is disabled. So actually this can be set globally. So by the time you obtain a connection from the connection pool, it's already set to auto-commit false. And here, using this property, you're actually telling Hibernate that you already took care of the auto-commit mode. So it can ignore it. So it will not have to, when you enter the transactional block, it will not have to go to the database, get the connection, and call auto-commit mode. So then you can delay the connection acquisition until you really need it, which actually happens when you call flush or when you want to execute a query. And the difference is here. Now, the processing time would be here, so then you save a lot of time because here you only had to took the connection for only 40 milliseconds, but then the processing took more than 100. So actually you can save a lot of time because you can reuse the connection much more efficiently than, for instance, if you don't have this property. So all these properties are somehow have been added from Hibernate 5.2. So if you have an application, it's a very good. It's worth investigating if it's convenient for application to upgrade to 5.2, 5.3, and 5.4 is going to be launched pretty soon. With that, thank you for coming, and I hope you enjoy my talk. Now, if you have questions, you can ask me here. Otherwise, I can answer all the questions on the hallways. Thank you very much.